Hi, let's try to solve a question on time value of money. So this is a question on time value of money. An investor, he plans to retire at the age of 60. He's expecting to live till the age of 90, and current age is also given, it's 25. He is investing the first payment today and expect to invest for more 35 years. That is like he will be making total of 35 investment. Here it is said that the retirement account earns 12% per annum. So here we will have to assume that this rate he will be able to earn even when he is retiring. Okay, otherwise in the problem, some problems they may give you different return during the investment phase, different return during the retirement phase. Okay, and then it is said that he is withdrawing $30,000 per year from the point when he turns 60, and he will be doing it for the 30 years. Okay, and we are interested in finding out how much he should deposit in the retirement account every year. Okay, in most of these problems, like it would, you have to assume that investor does not leave any money for his children. Okay, but here we have given it, so assume that investor does not leave money for their heirs, but you have to assume if it is not given. Okay, so how do you solve this type of problem? Okay, so for solving this type of problem, what is required is we have to draw timeline. So this is known as timeline. Okay, so we have to come up with a timeline. In timeline we will express the amount versus the time. Okay, so here the question says that he's age 25 and he start depositing the first money at this point. So we'll say that the amount he is depositing we don't know, and we are mentioning it as X. Since the money is going out, we will say it's negative. Any outflow, you can take a sign convention as outflow should be treated as negative and inflow should be treated as positive. Okay, and he will deposit, and he is making a total payment of 35 payments. So he is making 35 payments. Now how do you know that at what age he will be finishing off his payments? Okay, now when the number of payments are very high, I would not recommend you to count on your fingers and compute it. Okay, a very simple way to find that is, just think over here, he is investing on 25, on 26, and he will go on till I do not know n. Okay, so what we have is 26 he is depositing and 25 also is depositing. So 26 minus 25 is how much? Is 1. But how many payments he has made? He has made one payment over here, he has made two payments over here. So he has actually made two payments, so we will have to add a one payment over here. Okay, so let us see that at the nth year, let's say over here nth year, he will be making total payments. So nth minus 25 is the difference, and we have to add 1 over there. It should be equal to, since we are saying that it should be making a total of 35 payments, so it should be equal to 35. So this implies n will be equal to 35 minus 1 plus 25, which comes to 59. So at the 59th year, when he turns 59th year, he will be making the last payment. So last payment is done on 59th. Okay, and the question also says that he starts withdrawing the moment he becomes 60. So the moment he becomes 60, he will start withdrawing. Correct? So he has started withdrawing the moment he has become 60. So here he has retired, and just when he is retiring, he is withdrawing the first payment of $30,000. Okay, now you have to find out till when he will be withdrawing. Okay, so it is also mentioned that he is expecting to live 30 years after the retirement. So 60 plus 30, he is expected to live till 90 years. Okay, but would he withdraw the last payment on 90, or would he withdraw the last payment on 89 or 88? Again, we can solve it using this concept. So let us see, when he turns 61, again he will withdraw 30,000. So we can say 61 minus 60 it is equal to 1, but he's actually made 2 payments, so whatever the difference we have to add 1 over here. Okay, and let's say on the nth year he withdraws the last payment, so nth minus 60 plus 1, he should be withdrawing total of 30 payments. So 30 payment he is withdrawing, so we can compute n as 30 minus 1 plus 60, so it is 89. Okay, so 89 is when he will be withdrawing the last payment. Okay, now many people would solve this blindly without considering this, but I would say that here most of the data was given in the question. Do not try solving without drawing a timeline. Okay, if you draw the timeline, you will be able to achieve accuracy rate will be very high. Okay, accuracy rate will be very high, and the chances of making mistake is low. I would say that 50% of the problem is done the moment you have got the timeline. Okay, so this is the timeline we have received. Now what we have to do is we have to find out when he will be receiving the payments. So here he has got 30,000 he is depositing. So what we have is this problem can be divided into two parts. Okay, one part would be this part, that is when he is withdrawing the money, so that is his withdrawing phase. That is the one part, and another part is when he is investing. So this is the other part where he is investing. So this is the two parts that you have. Okay, now using your financial calculator, what you can do is you can find out the present value of this part. So you can find out the present value of this part. Okay, now you have to understand where the present value will come. So now what we have is we have the same timeline, and we have divided it into two parts, like withdrawing phase and investing phase. When you are seeing the withdrawing phase, so here you are depositing this $30,000. Now your calculator, if you will be using the financial calculator from Texas Instrument, okay, you will be able to find out the present value of this part. Okay, so here you know all the values, you'll be able to find out the present value. Remember, in the Texas Instrument calculator, when you are working in the end mode, the present value is one period before the first payment. The present value is one period before the first payment. Okay, so in this part, when we are withdrawing, we have to compute the present value. So since the first payment is over here, you will get the present value at this point. Okay, also in this case the future value will be taken as 0, because as we had said that he is not leaving any money for his children. Okay, so in that case what we have is what are the input that we will do it for the calculator. In the calculator we are interested in finding out the present value. Okay, what I would say is follow your calculator. In this calculator, follow the convention wherein you are following a pattern. Let's say you are following a pattern from here, n, I by y, PV, PMT, that you are following. So what you can do is first you can put the value of n we know is 30, then I by y, that is the interest rate, which is 12% per annum. Okay, PV we have to compute, PMT the value is not is given, it's here $30,000 is given. Since we are receiving the money, it is plus 30,000, and FV is 0. So we'll input the same over here in your calculator. So before solving, we'll clear all the work. So second FV, it will clear all your work. Then you will have to put n as 30, I by y as 12, PV is not required to be put, 30,000 is your PMT, and future value is 0, and you will compute the present value. So the present value comes as 2416552. So what we have already said is this is the present value over here. So the present value is 241655. Okay, so that is the present value at this point of time. Okay, next what we have to do is we have to find out how much he has to deposit this money X. Okay, so in this part, the investing part, what are the things you know? In this investing part, we know that n is 35, we know that I by y is 12. Okay, PV is 0, because here is what we are starting, so PV should be taken as 0. Okay, PMT, no, PMT is not known to me, but what would be FV? FV of this part, if you see, what we are doing is we are investing the money over here, and that money is being consumed when he is retiring. Okay, so what we can say is whatever the money that he has in the withdrawing phase, it has come from this accumulation. So the present value of this withdrawing phase over here should be equal to the future value of this investing phase over here. So what we can say is present value of withdrawing is equal to the present value of, is equal to the future value of investing phase. Now with that is known, so what we can put is we can put this future value over here. Okay, and then we can go on and compute the PMT. So let's see, whatever this future value is there in the calculator, we can put over here. So FV, so FV, PV will become FV, PMT is like we'll put 0, PV we will put 0. What is N? N in this time becomes 35. I by Y remains the same. Just if you want to check what is the value of I by Y you have stored, what you can do is you can press this recall button and press this I by Y. So you will see that whatever is the value stored in the calculator. Okay, and here I am using the BA2 plus student edition, but the same process is applicable in the BA2 plus professional edition also. Okay, so that means now next time we have to compute the present value. For computation we'll have to press this compute button and press this PMT button. Okay, so what is the answer? So you get the present value of the PMT over here as 551.82, or roughly I can say is $560. So he should be investing $560, and you can understand the process of compounding. That $560 has become $30,000. So that is what the power of compounding is there. So it's advisable that you should start investing as early as possible. Okay, so thank you for watching this. This is Ratan Gupta from Knowledge Varsity. Thanks.